Okay, as I was telling you, this is for finding the relation between y is less than or equal root of x and y is greater than or equal to x minus 1. Y is greater than x minus 1, it's all the points that's above the line y equal to x minus 1. And for y is equal to root of x, it's the set of points of root of x. So once more, if I want to draw root of x, this is y equal to root of x. طبعا y equal to root of x, it's going to be the above wing and the lower wing. But since we are talking about y is root x is only defined for x is greater than or equal to 0, we have that x is greater than or equal to 0 implicitly. So I'm talking about the above part only of this line, of this curve. And for y equal to x minus 1, this is going to be the shape of y equal to x minus 1, except in x equal to 0, so you add negative 1, putting y equal to 0, so you will have x positive 1, then I will connect them together. So that's the shape of y is equal to x minus 1, but we are talking about y greater than x minus 1, that means the points above and less than root of x, these are the points or the region that we are talking about. So as I told you, this is the region. I can identify any ideas if I want to determine this point, if I want to determine the point of intersection between the line and the root, what to do. If I want to do this or to identify the point between both of them, all I have to do is to solve this equation. So I will have x plus 1 is equal to a root of an x, then square both sides, then x will equal to x plus 1 to the power of 2, which is going to equal to x plus x squared plus 2 of x plus 1. That's the equation. Try to move them all in one side. You will have x squared plus 2x plus 1. That's the equation. Of course, this is negative 1. I'm sorry. So that's going to be a negative of a 1. So it's going to be a negative of 2x plus 1, as you can see. So once more, this is how to get, to solve or to identify the root or the intersection point, which will happen at 1 plus root 5 over 2 by solving this quadratic equation. You will have root of x equal x minus 1. Then start squaring both sides. You will have x equal to x minus 1 to the power of 2. Expand it and then try to factorize it. If you did so, you will be able to identify the point of intersection, as you can see. So for the interior, it is all the points that's inside root of x, and y is greater than x minus 1, and x is greater than 0, as you can see. The boundary points are y equal to root of x, and y is greater than or equal to x minus 1, or y belongs to x minus 1, and y less than or equal to root of x, or x equal to 0, and x equal to 0, and y running from negative 1 up to positive 1 if I want to describe the region exactly. The exterior points are the points outside root of x and less than or x less than 0, or y is less than x minus 1. Remark that the isolated point is phi. I don't have any isolated points regarding the boundary or the b dash, the closure. It will contain the boundary and your interval as we have previously. B is not an open point, as an interior doesn't equal to B, and the B is closed because your area doesn't contain and tends to infinity from any of the sides, so it is a closed interval. This problem also y is equal to root of x. if I want to determine the boundedness, B is bounded as it is possible to define an open ball containing B, for example. B is a subset of B epsilon at 10 at point 0, 0, and the intersection doesn't equal to, there is an intersection between them, so it is belongs to R2 such that x squared plus y squared is then 100. And that's an example of the bounded, that the area can be bounded. Also 0 and 1, if you remark for the point 0 and 1, this is x equal to 0, Judy, and that's 1, that's the point. 0 and 1 belongs to interior or boundary, it's an exterior point. طيب عرفت منين 0 1 exterior point؟ لأن at the point of 0 and 1 you can write an open ball that's completely outside your region. This is why it's an exterior point, because B, an open ball centered at 0, 1 can be drawn and completely out of V. Example, B epsilon at 0 and 1. It will be x squared plus x minus 1, which means the circle that I can draw around here with epsilon very small over 0, 1 or something, and it will be intersection, your region will be phi, okay? Also an interior point, 1 and 0, for example, the point at x equal to 1 and 0, which is considered an interior point of V because an open ball centered at 1 and 0 can be drawn and completely contained in B. Actually, point 1 and 0, it's a boundary point. I will change it to be 0.5 and 0, which means a point inside the area exactly. I've tried just only to give you another example of an interior point. The point 0, 1 is a limit point of V because it is the limit of a sequence of elements. If you try to get 1 minus 1 over n, okay, you will find that the limit of 1 minus 1 over n is equal to 1, so it's considered a limit point of this interval. Also, look to this example, which is really very important one. ساعة كام دلوقتي معاك؟ Okay? 11. Okay. Let me just check for this slide. If so, I can move it till tomorrow. Okay. خلينا نخلص السلايدز دول، مجموعة السلايدز دول، والجزء اللي ما تسجلش the part of this lecture which was not recorded the beginning. I will share another part, another bunch of videos talking about the topological definitions in Rn, okay, in order to compensate the miss of record for the first part of this lecture. Okay, let me finish this example also. It's a very nice example. Okay, here he wants you to draw the set of 4 minus x squared minus y squared times x minus y, which is greater than 0. Actually, this set, it's not a nice one to draw, because this set contains 2 brackets in x and y, and each one of them, sometimes it is positive, sometimes it is negative. Are you with me, Judy? So, for this guy only, for some values of x and y, it can give an output of positive and negative. This guy also, for some values of another values of x and y, it may be positive or negative. But I need the multiplication of both of them to be greater than 0, which means I will have to find the interval of the first bracket معايا, and the interval of the second bracket where I'm sure they are both positive, and then I will consider this is a part of my region, and also I will have to flip it to get when the first bracket is equal to negative while the other is equal to negative, and they intersect them together. تعالوا نبص عليها. So first I will have to solve 4 minus x squared minus y squared in the case of greater than 0. So now I will have outcomes coming from the first bracket positive. And also at the same time, Judy, x minus y must be greater than 0. So I will try to solve both of them. This equation, actually, I can move negative x, equality, can move negative x squared minus y squared to the other side. And in this case, I will have x squared plus y squared less than or equal to 4, which means a circle with radius 2 centered at origin 0 and 0. That's the shape of the circle. Here is the circle, that's the boundary, if it is equal. And since I'm talking about less than, so I have the points inside the circle. تمام؟ يبقى points inside the circle are going to be a positive or will lead to a positive bracket. طيب تعالوا بقى for x minus y. x minus y is greater than 0. امتى ده يحصل؟ يحصل لما يبقى ال y less than x or x is greater than y. طيب x is greater than y, it means first this is y is equal to x. That's the line of y is equal to x. That's the line of y equal to x. I'm talking about y is less than x, so it is the points as you will see down there or beneath this line. So for the first set, it's gonna be the intersection. I need the positive points. For both of them if you multiply them together. أنهي حتة تبقى معايا؟ شايف أدهم؟ ده الجزء اللي يبقى موجود معايا بس. Which inside the circle and belongs to this strip. This is the set of points that will satisfy that these two brackets, when you multiply them, the result will be positive. In a similar manner, I will study the case of having the first bracket less than 0 and having the second bracket less than 0 also. بص بقى هعيده تاني بس يبقى less than 0. اهو بصي خلاص انا حددت الاريا اللي انا عايزها بالنسبه للانيكواليتي الاولانيه. Almost are less than 0. يبقى الفيرست براكت والسكند براكت less than 0. طب يا ترى الريجن ده يجي ازاي؟ الريجن ده يدي لك x سكوير بلس y سكوير greater than 4. يعني ده يعني ايه ادم؟ يعني بوينتس اللي بره السيركل. intersection x is less than 1. طيب يعني اذا دي اهي السيركل، دي البوينتس الاوتسايد السيركل، ودي البوينتس اللي هي x is is less than y, so it will take the other side as you can see. So now I will have the points in common which are this set. شايفة؟ دي الست بتاعتي. طيب I will combine them together. يبقى إذا لما أعمل لهم combination together, that's the set that I'm talking about. يبقى 4xy belongs to r square such that 4 minus x square minus y square times x minus y is greater than 0. This is the set representing what we are saying. تمام؟ طيب for this set, is it bounded? Is this set bounded? شايف الست دي bounded؟ في جزء منها bounded which is inside the circle. بس في strip تانية مش bounded. يبقى إذا الست اللي موجودة دي it's not a bounded set. تمام يا شباب؟ It's not bounded. طيب اهو تاني once more. يبقى الانتيريور of an S it is xy belongs to r square such that 4 minus x square minus y square times x minus y is greater than 0, and that's the region that I'm talking about. Okay, جميل جدا. For the 2 points خلي بالك for the 2 points دول البوينتس دي belongs to the interior of your set. اهو دي البوينتس دي بالنيبرهود بتاعتها completely contained, so they belong to this set. خلي بالك الانتيريور of an S are all points who are centers of an open balls fully contained inside the set, so the interior of the set is equal to the set itself, and it is an open set since this is satisfied. Okay. طيب لو انا بتكلم على الباوندري، لو انا جيت ابص للباوندري طبعا ديت الست بتاعتي، لو انا بتكلم على الست of elements that exist on the boundaries، دي البوينتس اللي المفروض هتبقى موجوده على الباوندريز بتاعت الست بتاعتي. طيب يبقى اذا الفرونتير is gonna be xy which is 4 minus x square minus x minus y square times x minus y, and both of them equal to 0. يبقى انا بجيب الباوندريز. هنا جبت البوينتس بتاعت الانتيريور، هنا حطيت الباوندري. A boundary point are those points who belongs to both the yellow and the white sets together, so it is the points of that their intersection with the interior and exterior. It's not an empty set, they have the points. The closure, that means this relation is not going to be greater than, it's going to be greater than or equal because it is the interior points plus the interior, خلي بالك, the interior points plus الboundary, so it's gonna be greater than or equal to 0. That's the closure of your set. وانا حطيت لك البوينتس برضو عشان توضح الانتيريور بلس الباوندري. Is this set compact؟ لا طبعا الست دي ما هيش compact، لأنه compact معناه إنها تبقى closed وتبقى bounded، وهي ما هيش bounded. طبعا أهو no it's not closed. The set يبقى S X Y belongs to R square. It doesn't equal to S, so it's not closed. Since our set is not closed, we can say it is not compact. Also, if we discuss the boundaries, as you will see the boundaries here if you have x less than -2 كل ده موجود معاك صح؟ x less than -2, so it's not bounded, so it's also not a compact set. وانا كتبت لك الكونديشن. طيب examples of an exterior points دي هتبعكس العلامه بدل ما هو greater than تبقى let them that stand for the points for the exterior. I've solved some of the examples on the workbook from the sheet of this part. So for this problem by itself, okay, okay, let me stop at here and I will continue tomorrow inshallah. كفاية قوي اللي أنا اديته لك النهارده. Thank you very much. I will try to share some vids as fast as possible. Hopefully the camera I will be able to see the any possibility for the recorded part. Thank you.